In this lesson, I'll give you an overview of Android resources and lay the groundwork for the following lessons on some resource topics. In these lessons, I'll use the API Demos app and other apps to show examples of resource use. As shown in this page from the developer's website, main resource types include animation, color state, drawables, layouts, menus, strings, styles, and some additional types: Boolean, color, dimension, ID, integer array, typed array. There are a number of useful web pages on the Android developer's website explaining resources. The concept behind resources is to separate them from Java code for a few key reasons. One big reason is to allow runtime changes for localization. For example, to change text to other languages for devices in a given country. Another is to allow layout changes for different device sizes and types, and to allow changes for screen orientation, portrait versus landscape. Still, another reason is to allow better management and control of app resources in the development process. A text string located once in a resource file is better than hard coding that string into various Java code files. For any resource, you can specify a default resource and multiple alternative resources. On the developer's website, for example, we see an example diagram where a default layout would appear the same except stretched on a smartphone versus a tablet. And with multiple resources, there could be one layout for a smartphone size and another for tablet sizes. We saw a simple example of using resources in our first app project. The folders with dashed alternative names, such as drawable-HDPI, are providing resources for, in this case, high-density display screens. The folders without dashed alternatives provide default resources, such as values in this example. The various versions of our launcher icon for high, low, medium, and extra high-density screens allows Android to display an icon that looks right on a wide variety of screen types. As apps grow larger and more sophisticated, the number and types of resource files can grow to fairly large numbers. Imagine if you want your app to display differently on everything from smaller smartphones to larger tablets, and then imagine the number of text translation alternatives you would need to offer native language support for many countries around the world. You could easily end up with hundreds of resource files. Another advantage of the separation of resources from Java code is that for larger projects, resource files can be managed by a user interface team separate from the Java coding team. They can work relatively independently and in parallel to simplify and speed up the development process. That's our overview of the resources chapter. Now let's move on to the next lesson. In this lesson, you'll learn about how to provide various types of basic default resources in your apps so they're available to your app Java code and the Android system. To start with, let's look at a resources example from the API Demos app. In the Demos worksheet, we can filter to find the entries. Now, I remember that they're designated in the secondary group. I can filter on that column for resources. And we find that we have 5 entries. Now, if you don't remember what column might contain the keyword you're using, you can progressively filter on each column. But let's check out the resources demo and notice that it has a Java file name of resources sample. Now let's fire it up in the emulator, and we see that these demos are in the content primary group. So we click on content, then resources, and we see our demos. And we're going to start the demo called resources. It's displaying 3 lines of basically the same text with the elimination of any formatting in the middle string. Now let's open the resources sample Java file in Eclipse. So I'll double-click the resources sample Java file, maximize it, and in line 47, we see that the set content view designates the resources layout XML file. So let's go down to the layouts, and we'll find the resources XML here. Double-click that. And in that file, we see we have a linear layout with 3 text views. Each of these text views designates an ID, such as styled text, and formatting parameters for width, height, gravity, and text style. Now, if we go back to the resources sample Java code, we see that the Java code is using the ID styled text to access this resource. And we'll learn more about the Java code access to resources in the next lesson. For now, we'll concentrate on the resources themselves. So let's take a look at some more detail about resources. The Android developer's website has an informative page on providing resources, which we see here. It has a good table explaining the different types of resources. And this table has some useful references to other developer pages using hyperlinks, such as here for property animations and here for tween animations. So let's just take a quick spin through them. The animator directory that has XML files that define property animations, the anim folder for tween animations. Color contains XML that defines a state list of colors, and this facilitates color changes depending on the state of the view object. For example, when a button is pressed, focused, or neither, there would be color changes between those. The drawable folder contains bitmap files such as PNG, JPEG, and GIF files. The layout folder contains XML that defines a user interface layout, and we've seen a number of these. The menu folder contains XML that defines app menus, such as options menus. Raw contains arbitrary files in their raw form, and to access these files, you would need to use the Asset Manager class. Values folder contains simple values such as strings, integers, and colors, and these are usually divided into subfolders such as strings, colors, and styles. And XML folder contains arbitrary XML files that can be read at runtime using the getXML method. So these are the kinds of default resources you can provide for your apps. And of course, you probably won't use all these types for every app, but most apps will contain at least drawables, layouts, menus, and values. So that's our lesson on default resources. In the next lesson, you'll learn about alternative resources for enhancing your apps. In this lesson, you'll learn about alternative resources that can be used to customize your app for various languages, countries, devices, and more. First, let's take a look at how to specify alternative resources for specific groups of devices. To provide an alternative resource, you append a qualifier to the basic default folder name using a dash. For example, in our first app, we used -HDPI appended to drawables to designate images for high-density screens. There's a table in the developer's website providing resources page that's shown here, detailing qualifying name options. As you'll see as we go through the options, there seems to be a bewildering and large set of choices to make. Which options are used for an app will be highly dependent on the nature of the app and the markets it serves. Keep in mind that alternative resources can be added over time. So you could start with a basic, fairly universal setup with just default resources, and then add qualifying resources as you customize for different markets. And they can be added without changing your Java code. So don't be intimidated, just take in the information and factor it into your app development at the right time. And you can find additional useful information about using alternative resources on this page on the developer's website. So here are the options. We have MCC and MNC, which are mobile country codes and mobile network codes that let you customize for country differences. Language and region lets you provide translations for different languages and regions. Layout direction lets your app adjust a layout depending on left to right languages such as English versus right to left languages such as Arabic. Smallest width allows adjustment based on the smallest width of displays on a device. Available width specifies a minimum available screen width at which the resource should be used. Available height specifies a minimum available screen height at which the resource should be used. Screen size specifies resources for small, normal, large, and extra large screen sizes. Screen aspect specifies long and not long ratio options. Screen orientation specifies portrait and landscape orientation options. UI mode specifies options for different types of devices such as car, desk, television. Night mode specifies night and not night options. Screen pixel density specifies options for different screen densities such as low, medium, and high. Touchscreen type specifies no touch and finger use modes. Keyboard availability specifies keyboard type options such as exposed, hidden, and soft. Primary text input method specifies options no keys, QWERTY, and 12 key. Navigation key availability specifies exposed and hidden options. Primary non-touch navigation specifies options such as trackball and wheel. And finally, platform version specifies options such as the different version numbers, version 3, 4, 7, etc. And now let's look at some examples. For some examples of alternative resources, you can scan through the API Demos resource folder, and the app contains default animation folders, a default drawable folder, and alternative drawable folders for different screen densities, a default layout folder, and alternative layout folders for different screen dimensions, a default menu and raw folders, a default values folder, and alternative values folders for different screen densities, dimensions, and release numbers, and a default XML folder. Now that's our lesson on providing alternative resources. Now let's take a look at how resources are accessed. In this lesson, you'll learn how to access your app resources from Java and XML code. In the emulator, let's take a look at the styled text API demo shown here on the worksheet, and it'll give us an example of accessing resources. Let's fire it up by clicking on Content, Resources, and then Styled Text. And we see two groups of text. In the first group, text is initialized from a resource in the XML layout file. And in the second group, the text is initialized programmatically from Java code accessing a resource. Let's take a look at the styled text Java code for this demo. So we'll open the styled text Java file, maximize the window, and in line 40, the setContentView method is used to display the screen using the styled text layout. So let's open the styled text layout file, go down to the layouts, expand that. So the first, second, and fourth text views, notice that there's a text parameter specifying a string resource. For example, in the second text view at line 33, there's a reference to the styled text string. Now let's look for the styled text in strings. So if we open the strings resource file, we see a huge number of strings defined. It's actually well over 1,000. We go down to the bottom and look. Now the API demos is big and it has a lot of different resources, including strings. So we'll need to search for it. Let's click on Search. And I already have styled text in here. Click on Search. There's some problem with search. It's actually working. It doesn't think it is. So we'll just say OK. And now if we look here, see this little indicator for line 412. Let's click on that. There we go. So here we see the styled text references that it found. The one we're looking for is in line 413. And you can see that it's formatted with the bold italics and bold italics tags that gives it this formatting we see here in the display. Now back in the styled text Java file, in line 46, we see the getText method is used to retrieve the styled text string from string resources. And the r.string reference identifies the string resource file as the place to look for the styled text value. And in line 47, a text view is created using the findViewById method with the text ID as a parameter. And in line 48, the setText method is used to change the text in the TV text view. Note that the qualifiers in the references r.id are telling the system where to go to find the right resource. So to summarize, in statement 40, the first group of text is set in the display using a string resource reference coded in a layout. And in statements 46 through 48, the second group of text in the display is set programmatically by retrieving the string from the string resources. On the developer's website, there's a good page with additional detail about accessing resources, giving information such as syntax details and use cases. And I encourage you to review this. That's our lesson on accessing resources. Now let's take a look at localizing your apps using resources. In this lesson, you'll learn how to localize your app resources for specific languages and regions. The resources you might want to localize include text strings, audio files, numbers, currency, and graphics. As an example, let's take a look at the strings resource file for the API Demos app. Open that, maximize the window, and it contains a large number of strings. As we've seen, it's over 1,000, and that's a lot to handle. However, all the default text is located in this single file. So to translate all this text to other languages, this file could be sent to a translation service with instructions to translate the text portion of each string, and that would be the characters that are shown here in black. You might want only a handful of different language translations, or you might want dozens, depending on your approach to your markets. Also, keep in mind that you can roll out support for different languages over time. You don't have to do them all at once. As you add translations to your app, when your app users update their devices with the latest version of your app, they'll automatically get any additional translations. And the system will use the translation for their country or region if it's available on the app. Otherwise, the default strings will be used. These defaults are often the English language versions, but they don't have to be. And you can add these translations without changing your Java code. This gives you tremendous flexibility in handling localization over time. And now let's take a look at the syntax for localizing your resource folders. As we saw in the lesson on providing resources, on the Providing Resources page on the developer's website, shown here, localized resource files are designated by appending a language code, shown here, to the resource folder name. For example, FR for French. And there can also be an optional region code, such as -RCA for Canadian French. The language codes are defined in the ISO spec 639-1, and a link is included here. And the language codes are in the second column. The region codes are specified in the ISO spec 3166, and there's a link here to that. And remember to include the dash before the specification of a region, which should also include the R. So it's a -R, US, -R, FR, and so forth. And the developer's website also includes a localization page that provides additional details, including localization strategies and testing. And I recommend you review these topics before moving ahead with localization. That's our lesson on localization. It's a powerful tool for increasing the appeal of your app in regions and countries around the world.